This is Lab 1, Charge Tapes. This lab is about observing the interactions of charge tapes and calculating the excess charge on tape B. The fundamental principles used in this lab include conservation of charge, electric force, and gravitational force. The charge of tape B during the experiment was found to be 1.684 times 10 to the negative 8 coulombs. And the charge calculated by the computational model is 1.686 times 10 to the negative 8 coulombs. The ratio of electrons to atoms on tape B during the experiment was found to be 49.13. In this video, we will go over the observations, measurements, and calculations made in the experiment and in the computational model. During the experiment, it was found that two U-tapes will repel each other, and a singular U-tape is attracted to neutral objects and attracted to negatively charged objects. From these statements, we can infer that the U-tape is positively charged. The net Y component of the force on tape B is 0, and the vertical forces on tape B include the electric force and the gravitational force. From this, we can infer that the magnitude of the electric force is equal to the magnitude of the gravitational force. The length of tape B was measured to be 0.214 meters. The mass of the tape B was found to be 0.000214 kilograms, and the distance between the two tapes when one is floating above the other is 0.034 meters. The magnitude of the gravitational force and the magnitude of the electric force on tape B is 2.0972 times 10 to the negative 3 newtons. The magnitude of the gravitational force on tape B was calculated by multiplying the mass times the gravitational acceleration. The charge of tape B was found to be 1.684 times 10 to the negative 8 coulombs, and was found by taking the square root of the electric force multiplied by the distance between the two tapes squared all over the constant K. The number of electrons on tape B was found to be 1.05 times 10 to the 11th electrons. This was found by taking the total charge Q and dividing it by the charge of an electron. The number of atoms on tape B was found to be 2,143,125,000 atoms. This was found by multiplying the length of the tape times the given length dimension of an atom. The ratio of electrons to atoms was found to be 49.13. This was found by taking the number of electrons and dividing it by the number of atoms. A computational model was made, and it shows two charged tapes exerting an electric force on each other and experiencing a gravitational force. It's used to estimate the amount of charge on each tape necessary to float one tape above the other. The magnitude of the charge on one piece of tape, as calculated by the computational model, is 1.686 times 10 to the negative 8 coulombs. In order to determine the amount of charge on the floating tape, tape A and tape B are both treated as point charges, where all the charge is located at a single central point on the tape. Also, both U-tapes are assumed to have the same charge. Below is a photo taken from the computational model where tape A and tape B are treated as point charges. This first photo shows the electric force and gravitational force acting on tape B in the form of arrows in the computational model. The second photo shows the charge calculation in the computational model. This is the final output of the code. The yellow arrow represents the electric force on tape B by tape A, the green arrow represents the gravitational force on tape B, and the orange arrow represents the electric field of tape A. In conclusion, the charge of tape B during the experiment was found to be 1.684 times 10 to the negative 8 coulombs. The magnitude of the charge on one piece of tape as calculated by the computational model is 1.686 times 10 to the negative 8 coulombs. This is a very small distinction, and is probably due to rounding errors. The ratio of electrons to atoms on tape B during the experiment is found to be 49.13. If electrons had positive charge and protons had negative charge, the charged tapes would be negatively charged instead of positively, although two U-tapes would still be repelled by one another. It is important to handle the charged tapes as little as possible because when the charged tapes come in contact with your own hands or other objects, electrons are transferred between them due to conservation of charge.